Hey everyone, this is DeGuila from Codecademy. In this video, we'll walk through the control flow lesson in the Learn Python 3 course. For each exercise in the lesson, we'll do a brief recap of what the lesson's narrative taught, and then we'll walk through the exercise's instructions where we'll apply our knowledge. Throughout the lesson, we'll cover a brief introduction to control flow, Boolean expressions and variables, relational operators, as well as if, else, and else-if statements. Let's get started. Exercise number 1, Introduction to Control Flow. In this exercise, we'll start off the lesson with a brief introduction to control flow in Python 3. So, what is control flow? Let's start by painting a mental picture. We can do this by thinking about the decisions we make on a typical morning. For this, we'll draw a decision tree, a graphic representation of our decisions. First, we need to decide what time we'll wake up. For example, if it's a weekday, we might wake up at 6:30 a.m. But if it's the weekend, we might instead wake up at 8:30 a.m. Depending on which path we took, we arrive at another decision. In the case where it's not a weekday, we'll decide if we need to go outside or not. And if we don't need to, we can stay in our pajamas. On the other hand, if it's a weekday and we had to get up earlier, we come to the decision on whether or not to wear a raincoat. This decision is determined by the condition of, is it raining, which produces a yes or no value. Control flow in Python, and other programming languages, is similar to the decision tree we made about a typical morning. Python executes starting at the top of the file and works downward. Decisions are made throughout the program based on certain conditions that we've defined. Depending on the condition, Python will determine the path of the code that needs to run. Similar to how some of our decisions were skipped in our morning example, certain parts of the program may be executed while others are skipped. Throughout this lesson, we'll take a look at how Python defines these conditions so we can create control flow. This exercise doesn't have an instruction section, so let's move on to a frequently asked question from the Codecademy community. Before we move on, let's look at one of the frequently asked questions for this exercise. You can find these in the community forum section under the instructions. A commonly asked question is, are decisions in control flow required to be binary? Do they have to be only yes or only no? The answer is yes. In control flow for a program, the decisions must be made from only yes or no answers, typically represented by true or false values. If, for example, we need Python to answer a question like, is my name Chris? We'll use true and false values to do so. These are called Boolean expressions, which we'll be covering in the next exercise. Exercise number 2, Boolean expressions. In this exercise, we'll talk about what a Boolean expression is and what does and doesn't qualify as a Boolean expression. So what is a Boolean expression? A Boolean expression is a statement which has an objectively yes or no answer. In Python, this is represented by a true or false value. Boolean expressions cannot be subjective statements, such as opinions. Let's take a look at some statements on the right to determine whether they are Boolean expressions or not. The statement, today is a weekday, is a Boolean expression, since, depending on the day, it will return either true or false. The next example is the statement, Sunday starts with the letter C. This is also a Boolean expression, since, although it is always false, it has an objective yes or no answer. The last example is the statement, Friday is the best day of the week. This is not a Boolean expression, since the answer varies depending on who's answering the question. There's no way to prove that Friday is the best day of the week. Being able to determine whether something is a Boolean expression or not enables us to write effective control flow in our Python programs. This is because programming languages don't inherently know how to handle values that aren't concrete, like true or false. Now let's practice Boolean expressions by tackling the instructions portion of this exercise. The instructions ask us to answer whether or not each of these statements is a Boolean expression. For statement 1, we have dogs are mammals. This is a Boolean expression, since it has an objective yes or no answer, and it's not an opinion. Dogs are classified as mammals, so we'll write yes. For statement 2, we have, my dog is named Pavel. Again, this is a Boolean expression, since the dog's name either is or isn't Pavel. So it has an explicit yes or no answer. so we'll write yes again. Statement 3 is, dogs make the best pets. This is not a Boolean expression, since it's an opinionated statement. The answer varies from person to person, and so we can't assign it a consistent true or false value. So we'll write no. Finally, the last statement is, cats are female dogs. Although this is a false statement, it is a Boolean expression since it has an objective yes or no answer. In this case, the answer will always be no, but it is a Boolean expression. So we'll write yes. And now let's hit run. And we can see that we passed the test. Before we move on, let's look at one of the frequently asked questions for this exercise. A commonly asked question by Codecademy users is, can Boolean expressions be combined into a longer expression? The answer to this is yes. Boolean expressions can be combined using Boolean operators, which we'll learn about later in the lesson. Some common Boolean operators are and, or, and not. Exercise number 3, Relational Operators, Part 1. In this exercise, we'll learn about 2 frequently used relational operators in Python and what they accomplish. Let's first start with defining relational operators. Relational operators are used to compare 2 items together. They return a true or false value depending on the result. Because of this, they are also known as comparators. 2 of the main relational operators are equals and not equals. These use double equal signs and an exclamation point followed by an equal sign. One of the common use cases is not only to compare values, but also to compare data types. Double equals will test if the data types are the same, then if the values are the same. Let's take a look at some examples on the right. First, we have 1 double equals 1, which returns true since the values are the same. Next is 2 is not equal to 4. This returns true since 2 is indeed not equal to 4. Then we have 3 double equals 5. This returns false since they are not equal, so the expression is not true. Finally, we have the string 7 double equals the number 7. This returns false since the data types are not the same. Now let's switch over to the lesson and go over the instructions portion of the exercise. The instructions for this exercise ask us to set each variable to true or false, depending on the results of the Boolean expressions. For each of these Boolean expressions, we can solve each side separately, then compare the 2 answers. Let's start with statement 1. First, we take a look inside the parentheses, since it has the highest order of operations. 5 times 2 is 10, then minus 1 is 9, and on the other side we also have 9. Now we use the relational operator, double equals, to compare the 2 values. Since they're the same, true will be returned. So let's set statement 1 equal to true. Next, for statement 2, we have a similar situation, but this time we're using the not equals operator. If we do the math, the left side of the not equals operator is 7, and the right side we also get 7. Now we compare the 2 values using the not equals relational operator, and this will return false, since 7 and 7 are actually equal. This is the same as asking, is 7 not equal to 7? The answer is no, or false. So let's set statement 2 to false. Finally, for statement 3, if we did the math, we get 3 on the left side and 3 on the right side. Because of this, when using the double equals operator, true will be returned. So let's set statement 3 to equal true. And we'll hit run. And we can see that we passed the test. Before we move on, let's look at one of the frequently asked questions for this exercise. One commonly asked question for this exercise is, in Python, what is the difference between equals and double equals? That's a great question. In Python, a single equal sign is called the assignment operator and is used when storing data in variables. Like in the exercise when we assign statements 1, 2, and 3 to be true or false. On the other hand, double equals is a relational operator used to compare 2 items, like when we were comparing the results of the expressions in the exercise. So in essence, both the single equals and double equals operators serve different purposes. Exercise number 4, Boolean variables. In this exercise, we'll explore the difference between regular variables and Boolean variables. So what are Boolean variables? Well, they aren't much different from regular variables, except for containing data with the data type of bool. And the only values of the bool data type are true and false. So to create a Boolean variable, we can either assign true or false to the variable directly, or we can assign something that will return a true or false value, such as a Boolean expression. Let's take a look at some examples of this on the right. First, we have two variables, one called set2true and one called set2false. These are assigned Boolean values directly. Next, we have a variable called bool1. This variable is assigned a Boolean expression, which will return either a true or false value. In this case, we have 5 is not equal to 7, which will return true. So bool1 will contain the value of true. Then we have bool2. This is assigned the Boolean expression 1 plus 1 is not equal to 2. Bool2 will contain the value of false, since 1 plus 1 is equal to 2. Finally, we have bool3 is equal to 3 times 3 double equals 9. The Boolean expression will return true, since 3 times 3 is equal to 9, and the result is stored in bool3. Alright, now that we've covered the basics of Boolean variables, let's go through the instructions for this exercise. The first instruction for this exercise asks us to create a variable named myBabyBool and to assign it to the string true. So let's write that in the code editor. We'll have my underscore baby underscore bool equals true. And we'll hit run. So we passed the test, but did we actually create the Boolean variable? Let's find out in the next part. For the next instruction, we need to print out the data type of myBabyBool using two functions, the type function and a print function. If we click the link in the instructions, we'll be taken to Codecademy Docs. Codecademy Docs is Codecademy's beginner-friendly and community-driven collection of code documentation for popular programming languages and frameworks like Python. On this page, we can read all about Python functions, including the type function. We'll learn more about functions in later parts of the course, but for now, the important thing to remember is that the type function is used similarly to the print function in the code, except type will allow us to see the data type of a specific value or variable. Let's return to the instructions and see how. So let's write print and type of myBabyBool. And we'll hit run. When we hit run, the data type str is printed in the console for string. This is because we created a string containing the text true and not the actual bool data type value of true. For the third instruction, let's fix this. Let's create a new variable called myBabyBool2 and assign it to the value of true. So we'll have myBabyBool2 equals true. This time we'll use the Boolean data type value of true instead of a string. And we'll hit run. And finally, for the last instruction, we need to repeat the steps of printing out the type of myBabyBool2. So similarly to before, we'll have print and type and myBabyBool2. And we'll hit run. Notice how bool is now printed in the console. This is because we assigned myBabyBool2 with the bool data type value of true instead of a string containing the text true. Before we move on, let's look at one of the frequently asked questions for this exercise. One commonly asked question by Codecademy users is, can true and false be used as normal variable names? The answer to this is no. True and false with capital first letters are reserved words known as keywords. They represent the two values supported by the bool data type. If you were to use true and false with lowercase letters, then technically they would be valid variable names, but doing so isn't recommended since it might be easily confused for Boolean values by others reading the code. Exercise number 5, if statements. In this exercise, we'll finally start to build control flow into our Python programs. We'll start by learning about the Python if statement and how it works with conditional statements. So what does an if statement do? An if statement is the coded form of a conditional statement. Conditional statements allow us to make decisions in our code, thus creating control flow. If statements use Boolean expressions to determine if certain portions of code should be executed or not. So if something is true, Python will execute some code. If it's false, then it won't. The syntax is the following structure. We use the if keyword, followed by a condition which determines if we should execute the code or not, a colon character to tell Python to execute the following code if the condition was met, then the indented code to execute. It must be indented because this tells Python that it's part of the if statement rather than the code outside of it. Let's take a look at an example on the right. Say we have a conditional statement written in a sentence format. If it is raining, then bring an umbrella. Within this conditional statement, we can extract a Boolean expression, it is raining, which will return true or false. In our example, this can take the form of a variable called isRaining. Let's assume it was set to true earlier in the code. Next, if we wanted to use this conditional statement to replicate the logic in the sentence, we can use the if keyword with the Boolean expression defined by isRaining. We can then set the control flow to print out the phrase, bring an umbrella. So if it is raining, then we need to bring an umbrella. We've successfully transformed the sentence into Python control flow. Remember, the indentation inside of an if statement is important. If the code below is not indented, it will not be properly executed. Now let's move on to the instructions for this exercise. For the first task of this exercise, we are asked to assign any string to the variable username. This program will check the username variable and run some control flow depending on the value. In this case, we're creating a program to keep a coworker off our computer. Let's go ahead and use the string Dave. And we'll hit run. When we hit run, we'll see an error come up, but the instruction will be checked off as correct. Not to worry, we'll fix the error in the next step. The next task asks us to debug the program to fix the error we're seeing in the console. When looking at the console, we see there's a syntax error, and Python is pointing us to the equal sign. This is because a single equal sign is the assignment operator and not a comparison operator. So Python is confused because, as we learned earlier, the if keyword requires a condition to come after it. In this case, username equals Dave is not a condition because of the single equal sign. To fix the error, we'll need to add an additional equal sign so that we're using the comparison operator and it becomes a Boolean expression. So let's add that in here. Let's hit run again and see what happens. Now Python is able to reach the print statement since the Boolean expression returns true because username was assigned Dave earlier in the code. For the last task, we're updating the program to stop our coworker from accessing our computer using a different name. We need to start by updating the username to equal AngelaCatLady87. So let's go ahead and make that change. Now we need to add a second if statement, which will print a different message if username is equal to AngelaCatLady87. This way we can catch our coworker if they use either username. First, we need to make sure that we're not indented from the first if statement. Then we use the keyword if, and we provide the condition. In this case, it's username double equals AngelaCatLady87. And after the Boolean expression, we use the colon character and move to the next line. And here, we need to make sure it's indented, since this is the code which will execute if the Boolean expression in the if statement is true. And here, we'll have a print statement which prints, I know it is you, Dave, go away. So let's add that in. Now let's hit run and see what happens. Our second if statement worked, and we have our custom message in the console. Looks like we secured our computer. If we scroll down, we can see there are a couple of community questions, but they're not in the scope of this lesson. We'll move on without going through a community question, but feel free to click on these and go through them yourself. Exercise number 6, Relational Operators, Part 2. In this exercise, we'll learn about some more commonly used relational operators in Python. There are several more common relational operators that we can use. For testing if one item is greater than another, we use the right angle bracket. For checking if something is greater than or equal to something else, we use the right angle bracket followed by an equal sign. The same applies for checking if something is less than. We can use the left angle bracket. And checking less than or equal to uses the left angle bracket followed by an equal sign. All of these relational operators return true or false. Let's look at an example on the right. Inside of our if statement, the condition is a Boolean expression which tests if age is less than or equal to 13. If this condition is true, then the message will be printed out. Now that we reviewed the basics of some additional relational operators, let's take a look at the instructions for the exercise. For the first task, we're asked to create an if statement for checking if the variables x and y are equal. If they are, then we need to print out these numbers are the same. To do this, we use the if keyword, followed by a Boolean expression for checking if x is equal to y. We'll use the double equals relational operator to test if x double equals y. Afterwards, we use the colon character to tell Python that the indented code under the if statement definition will be executed if the condition is true. Inside of the if statement, we'll add a call to the print function with the message, these numbers are the same. Let's hit run and see what happens. Looks like the code worked. Since the two variables have the same value, the message is printed. For the second task, we're asked to check if a student has enough credits to graduate based on a variable called credits. Here we can create another if statement, but this time the Boolean expression will test if the number of credits is greater than or equal to 120, since a student could earn more than 120 credits. So we'll have if credits is greater than or equal to 120. Then we'll use the colon character, and inside of the if statement, we'll have print, then the message, you have enough credits to graduate. And when we run our code, looks like we have enough credits. Before we move on, let's look at one of the frequently asked questions for this exercise. One commonly asked question by Codecademy users is, can relational operators be applied to values other than numbers? The answer to this is yes. Relational operators can be applied to many different items, including variables, strings, and other data structures which you'll learn about later on. Each data type has its own rules for comparison. Let's take a look at an example. Back in our code, let's try a couple of examples. Let's use a print statement, and inside, let's try comparing A is less than B. Let's see what happens. When we hit run, we can see true is printed to the console. Let's also try that with some symbols. Print $sign is greater than ampersand. When we hit run, we can see false is printed. So these characters are being compared. And that's because each character has a numerical representation in the background, which is used to determine the order. As you start writing programs with control flow, you'll start to discover the different conditional rules for different data types. Exercise number 7, Boolean operators, and. In this exercise, we'll learn what Boolean operators are and be introduced to the first one called and. So what exactly are Boolean operators? Boolean operators combine multiple Boolean expressions together to return one true or false answer. The three main ones which we'll be looking at in this lesson are and, or, and not. They're also known as logical operators. In this exercise, we're exploring the and Boolean operator. The and Boolean operator returns true if both Boolean expressions on either side of it are true. If either Boolean expression is false, then the whole result is false. Let's take a look at a few examples on the right. First, we have 1 plus 1 equals 2, and 2 plus 2 equals 4. The left and right side of the and operator are both true. Since we're using the and operator and both sides are true, the whole expression will return true. Next, we have 1 is greater than 9, and 5 is not equal to 6. In this example, even though the right side of the Boolean operator is true, the left side is false, so the whole expression becomes false. Then we have 1 plus 1 equals 2, and 2 is less than 1. Since the right side of the and operator is false, the whole expression is false. Finally, we have 0 equals 10, and 1 plus 1 equals 1. Since both sides are false, the whole expression will return false. Alright, now let's take a look at the instructions for this exercise. For the first task, we need to determine the answers for statement 1 and 2. For statement 1, we can evaluate the left side using 2 plus 2 plus 2, which gives us 6, and that's greater than or equal to 6, so the left side is true. And on the right side, we have negative 1 times negative 1, which gives us 1, is less than 0, and that's false, since 1 is not less than 0. And since one of the sides is false, in the case of the and Boolean operator, the whole statement becomes false. So for statement 1, we'll write false. Next, we'll look at statement 2. For this statement, on the left side of the expression, we have 8 is less than or equal to 8, and 6 is equal to 6. Since both sides of the expression are true, the whole expression becomes true. Now let's hit run. And we got it right. In task 2, we need to create an expression that prints a string if the GPA variable is greater than or equal to 2.0 and the credits are greater than or equal to 120. In script.py, we already have an if statement that checks the latter. Let's add the second Boolean expression and combine it using the AND operator. So here, we'll write and then GPA is greater than or equal to 2.0. Now we'll run the code and see what happens. As we can see in the console, since both conditions were met, the message was printed out. Exercise number 8, Boolean operators, OR. In this exercise, we'll learn about another Boolean operator called OR. So what does OR do? Similar to the AND operator, the OR operator has specific conditions it must meet to return true or false. The OR operator returns true if either Boolean expression on each side is true, or if both Boolean expressions are true. It will only return false if both Boolean expressions on both sides are false. Let's take a look at some examples on the right. First, we have true or 3 plus 4 equals 7. Since both sides of the OR Boolean operator are true, the whole expression returns true. Next, we have 1 minus 1 equals 0 or false. The left side of the OR operator is true, but the right side is false. Since only one side has to be true, the whole expression returns true. Then we have 2 is less than 0 or true. Since the right side is true, the whole expression becomes true. Finally, we have 3 equals 8 or 3 is greater than 4. In this case, both sides are false, so the whole expression becomes false. Now let's go through the instructions for this exercise. Similarly to the previous exercise, the first task asks us to solve two Boolean expressions and assign the results in two variables. For statement 1, the left side of the Boolean operator is 1 is greater than 3, so false, and the right side is negative 10 equals negative 10, so true, Since at least one side is true, the Boolean operator OR returns true. So let's assign true to the variable statement 1. For statement 2, the left side of the Boolean operator is 14 is less than or equal to 15, so true, and the right side is 7 is not equal to 7, so false. Since at least one side is true, the whole statement becomes true. So let's assign true to statement 2 as well. And we'll hit run. Looks like we got it right. The next task asks us to rewrite the if statement from the last exercise, but with different conditions. We need to print a message if we have either 120 or more credits, or a GPA of 2.0 or higher. Let's start with the if keyword, followed by our Boolean expressions. Our Boolean expressions will be if credits is greater than or equal to 120, or GPA is greater than or equal to 2.0. Next, we'll use the colon character, and indented below the if statement, we'll add a print function which displays you have met at least one of the requirements. So we'll add that in here. And now we'll hit run again and see what happens. Since the GPA was high enough, the code inside of the if statement is reached. Only one of the Boolean expressions needed to be true since we used the OR Boolean operator. Before we move on, let's look at one of the frequently asked questions for this exercise. A commonly asked question by Codecademy users is, when comparing one value against multiple values, can we separate each value with OR? The answer to this is no. In Python, you cannot separate each value with the OR operator since it would cause a logical problem due to the order of operations. It would technically not cause an error, but it would not perform as expected. Let's take a look at what this means. Back in our code, let's print the result of GPA equals 2.5 or 2.0 or 1.5. When we run the code, 2.0 gets printed to the console. So what's happening? In Python, non-zero numbers are considered truthy values, or values which act like a true Boolean value. Because of this, when Python reads the Boolean expression, it starts from left to right and returns the first instance of a true or truthy enough value. Since we're using the OR Boolean operator, it can return that value immediately since Python doesn't care about the rest. It knows that the result will be true already. If we used AND, it would have to look through the whole set of Boolean expressions. Since the first Boolean expression, GPA equals 2.5, is false, Python moves to the next Boolean expression, which in this case is just the value 2.0. Because 2.0 is considered a truthy value, it gets returned, and we can see 2.0 in the console. The last Boolean expression is ignored, since we're using the OR Boolean operator. Exercise number 9. Boolean operators, not. In this exercise, we'll learn what not does and how to use it with Boolean expressions. So what does the not operator do? The not Boolean operator flips the result of a Boolean expression. If the result would have been true, then false is returned. Otherwise, if false would have been returned, then true is returned instead. Let's look at some examples on the right. First, we have not 1 plus 1 equals 2. Since the Boolean expression on the right side would normally be true, the not operator flips this, and the whole expression returns false. Next, we have not 7 is less than 0. The expression on the right side would normally be false, but the not operator flips the result to be true. Great! Now let's go through the instructions for this exercise. Just like before, the first instruction asks us to solve two statements and store the results into statement 1 and statement 2. For the first Boolean expression, we have 5 plus 4 is 9 is less than or equal to 9, which normally would be true, but we have the Boolean operator not, which flips the result. so statement 1 will equal false. For statement 2, we have 8 times 2 is 16, not equal to 20 minus 4, which is 16. So normally this would be false, but the Boolean operator not flips that, and statement 2 becomes true. Now let's hit run. We got it right. The second task asks us to write 3 if statements using the not Boolean operator in reference to the college program we wrote earlier. The first case says, if credits is not greater than or equal to 120, it should print, you do not have enough credits to graduate. So let's write that. We'll start with if, then not, credits is greater than or equal to 120, then print, you do not have enough credits to graduate. Next, if their GPA is not greater than or equal to 2.0, it should print out this message. So once again, we'll have if not GPA is greater than or equal to 2.0, then we'll print your GPA is not high enough to graduate. And finally, if their credits is not greater than or equal to 120 and their GPA is not greater than or equal to 2.0, it should print out this message. So if not credits is greater than or equal to 120 and not GPA is greater than or equal to 2.0, then we'll print out you do not meet either requirement to graduate. Now let's hit run and see the results. And we pass the instructions. We'll learn to better control the order of the conditional statements in the next 2 exercises. Before we move on, let's look at one of the frequently asked questions for this exercise. Codecademy users on the forum have asked, why does not true double equals false work, yet true double equals not false doesn't? Take a moment to pause the video and think about it. Let's switch over to the exercise and take a look together. First, let's print not true double equals false. When we hit run, true is printed to the console like we'd expect. Now let's modify it to say true double equals not false. Now when we hit run, we get a syntax error in the console. This is due to the order of operations for Boolean and relational operators. The comparison operator double equals has higher precedence than the not Boolean operator, so it tries to execute first. This means that Python is actually executing the statement true double equals not. This is an invalid statement, so it fails. To fix this issue, we can use parentheses to force not false to execute first before the comparison takes place. Let's fix it and run the code again. So we'll surround not false in parentheses and hit run. We can see that true is printed to the console. Exercise number 10, else statements. In this exercise, we'll learn how to use else statements to improve our decision making. So what does an else statement do? An else statement executes code when the conditions of an if statement are not met. It's placed below an if statement and also uses a colon with indented code below it. If the condition of the if statement is false and the code is skipped, then the else statement's code will execute instead. For instance, let's look at an example on the right. We have, if age is greater than or equal to 13, then print access granted. But what if the age is less than 13? To handle this case, we can use an else statement which executes different code if the if statement's condition was not met. Using this else statement, if our age is under 13, we will get a message saying, sorry, you must be 13 or older to watch this movie. Now let's move on to the instructions for this exercise to practice else statements. In this exercise, we are returning to our graduation program. The instructions ask us to add an else statement to the existing if statement. The current if statement covers the condition if a student qualifies for graduation, But if they don't qualify, nothing currently happens since the code is skipped. To fix this, we need to add an else statement below the if statement and print out a message saying, you do not meet the requirements to graduate. So, below our if statement, let's type else, and a colon, and below that, we'll have print, then our message. You do not meet the requirements to graduate. And now when we hit run, we can see our new message pop up since the GPA is too low. We've successfully controlled our logic to account for two situations. One for a graduating student, and one for a student that shouldn't graduate. Before we move on, let's look at one of the frequently asked questions for this exercise. A frequently asked question by Codecademy users is it a good practice to include an else statement for every if statement? The answer to this is no. It's not usually a good practice to have an else statement for every single if statement in your code. This is because it's not always necessary to include it. Python skips the code indented under an if statement if the condition is not met, and sometimes that's enough. Including too many else statements can unnecessarily cause your code to be less optimized and more convoluted. They should only be used when you need something specific to happen if an else statement fails to execute due to its Boolean expression returning false. Exercise number 11. Else-if statements. In this exercise, we'll learn how to add extra conditions to if statements and better control the decision-making in our program. So what's the point of an else-if statement, pronounced elif in terms of syntax, if we already have if and else statements? Well, the else-if statement allows us to perform additional checks if the initial if statement fails due to a false condition. Because of this, else-if statements control the order of conditional statements. It forces only one of the statements to execute. Once one of the elif conditions is true and the indented code is executed, the rest of the conditions are skipped and Python moves on. An else statement will only execute if none of the conditions from the if or else if statements were met. Let's take a look at an example on the right. Let's say we have a program accepting donations and we want to print a custom message depending on the donation amount. We could write an initial if statement for an amount greater than or equal to 1,000, which gives customers platinum status. At this point, we could put an else statement, but that would limit our control flow to only two options. Instead, say we wanted to create 3 levels of messages for donations of 1,000, 500, and 100. We could do so using else-if statements. Here we have 2 else-if statements which check for different donation amounts. Finally, there's an else statement which will print a message about the bronze donor status. This message will only be printed if none of the previous conditions were met. Now that we've covered a bit of the basics of using else-if, let's go through the instructions for this exercise. Let's return back to our program about grades at school. The instructions for this exercise ask us to create an if, elif, else statement to calculate the student's letter grades. If their grade is 90 or higher, we print A. For 80 or higher, we print B. For 70 or higher, we print C. 60 or higher is D. Otherwise, it's F. So we'll start with an if statement. So if grade is greater than or equal to 90, we print the letter A. Now, to test another condition, we use elif. So elif grade is greater than or equal to 80, we print B. Now we continue on. Elif grade is greater than or equal to 70, print C. Elif grade is greater than or equal to 60, print D. Otherwise, else, print F. Now when we hit run, we can see that B is printed to the console, since the grade was an 86. Let's try changing the grade and see what happens. Let's change it to a 97. We get an A. How about a 62? Get a D. And a 30 is an F. So our program is working properly. Before we move on, let's look at one of the frequently asked questions for this exercise. A commonly asked question by Codecademy users is, in Python, is there a limit to the number of elif statements that are allowed? This is a great question. There is no limit to the number of elif statements, but there must be one starting if statement. Also, there can only be one else statement at the end of all of the elif statements, but having an else statement is not required. While there is no limit, you do want to consider how long your control flow gets. The longer it gets, the harder it becomes to read for yourself and other developers. Exercise number 12. Review. We've made it to the end of the lesson. In this exercise, we'll briefly touch on each of the topics we went over throughout this lesson. Throughout the lesson, we talked about Boolean expressions and how they return true or false values. We discussed relational operators and how they're used to compare items together. Remember that the most common relational operators are equals, not equals, greater than or equal to, less than, and less than or equal to. We went over Boolean variables and how they store the bool data type, consisting of true or false. We talked about Boolean operators and how they combine Boolean expressions together. The three we talked about are and, or, and not, but there are others you'll learn about as well. Finally, we went over if, else, and elif statements, and learned how powerful they are for controlling decision-making in a program. Let's look at a final example on the right. This example combines many of the topics we learned about to create complex control flow in a program. If the lesson is complete, and we're on the review exercise, then print out you finished the lesson. Otherwise, if the exercise is review, but the lesson is not complete, then print out that you missed an exercise. Finally, if neither of those conditions were met, then print out let's continue the lesson. Now let's wrap up the lesson by going over the instructions for the last exercise. The instructions for the review exercise ask us to write a program which will calculate the weight of a person based on the planet they're on. We're given a data table which includes the relative gravity for each planet, as well as the ID number for each planet. The data we're provided with in the program is the weight variable and the planet variable which contains the planet ID. We can use if and elif statements to check which planet ID is being used in order to calculate the correct weight. So let's start with planet ID 1. We'll have if planet equals 1, then weight equals weight times our relative gravity for planet 1, which is Venus, and that's 0.91. Now, for another condition, we use elif. Planet equals 2. We'll have weight equals weight times 0.38. Now we can repeat this for planet 3. Weight equals weight times, with Jupiter, it's 2.34. And we keep going on. Now for planet 5. Then finally, planet 6. That's 1.19. Finally, we'll add a print statement to display the weight. We need to make sure it's outside our if statement. Now when we hit run, we can see a new weight is printed to the console. So let's go ahead and change the planet. Let's try planet number 1. See that our weight changes. And let's try planet 6. So our weight changes based on whichever planet we're on. Now you may be wondering why we didn't just use a bunch of if statements, since the ID will never be 2 different IDs at the same time, and there won't be any overlapping. This is because Python skips the rest of the elif statements if one of them executes. This saves computational time and prevents Python from checking every individual if statement. That about wraps it up for this lesson. Thank you for watching this video, and we hope you enjoyed learning about the basics of control flow in Python 3. If you have any more questions, or want to get involved with the Codecademy community, head over to the Codecademy forums or join our Discord server. See you next time, and happy coding!